Solvent de-asphalting technology can be flexibly applied in a number of areas in the refinery and for upstream heavy oil upgrading applications. Two primary features of this technology include the relatively low energy intensity and that an economy of scale is not needed, in which refiners are not constrained by the need to install large SDA units and can economically deploy this technology in both small and large capacity projects. As a result, solvent de-asphalting can allow refiners to improve bottoms processing capacity without negatively impacting the energy efficiency of the plant with the addition of either a small or large capacity SDA unit. There are a number of commercial solvent de-asphalting technologies available to be licensed. Today's video will discuss commercial SDA technologies from the following companies: AMEC Foster Wheeler UOP, Axens, KBR, UD, and Well Resources. Note: discussions on Well Resources SDA technology will be shown later in the section Upstream Application of SDA Technology. In 1996, UOP and Foster Wheeler USA Corporation merged their solvent de-asphalting technologies to jointly offer the UOP-FW USA solvent de-asphalting process. Also licensed is SDART, whose main feature is a step-out process that boosts DAO yield by 10 to 20% while maintaining the quality of the DAO for feeding to a vacuum gas oil hydrocracker. The company also licenses ASCOT, a process in which pitch production is eliminated by feeding SDA bottoms to the coker. Commercially, over 55 SDA units have been installed by Foster Wheeler and UOP prior to the collaboration, and several ASCOT units have been deployed. This figure shows a process diagram for AMEC Foster Wheeler and UOP's SDA process. UOP's SDA process has proprietary structured packing internals for extraction column in fuels production, a rotating disc contactor for lubes production, and a 3-product configuration available. AMEC Foster Wheeler and UOP also license SDART, which uses a step-out process that boosts DAO yield by 10 to 20% while maintaining the quality of the DAO for feeding to a VGO hydrocracker. Other benefits include a 3-product SDA design, wherein the intermediate product is routed to a resin treating section to remove contaminants and reduce the molecular weight of the component, while the treated resin is then reprocessed in the SDA extraction section where it is selectively separated. The company also licenses ASCOT, in which pitch production is eliminated by feeding SDA bottoms to the coker. In this process, coke mix is reduced compared to operating a SIDAC unit alone to treat vacuum resid. Furthermore, heat integration provides energy savings. Axens offers his patent Solvol SDA technology for processing heavy crudes. Axens Solvol has often been deployed in conjunction with its commercial resid hydroprocessing technology. Its integrated applications technology working alongside either commercial or conventional FCC and hydrocracking to limit pitch production. It has been reported that 13 Solvol units are in use with total capacity reported at over 9.8 million metric tons per year, which is around 180,000 barrels per day. This figure depicts a process diagram for Axens Solvol process. This technology has a high operating temperature and low vertical velocity in the extractor. This process primarily uses C3 to C6 solvents. Heavier solvents, such as C4, C5 and light gasoline, are used to increase DAO yield. The DAO product has a metals content that is compatible with downstream operations, and part of the DAO product is pumped back to the extractor and strippers in order to preheat the feed to these units. Solvent recovery is in optimized supercritical conditions. Since 1995, KBR has been offering residuum oil supercritical extraction, or ROS, for refinery processing and heavy oil upgraders to process whole crude streams. Over 55 ROS units have been installed worldwide with a combined capacity of almost 1.3 million barrels per day. Aquaform is a patented method for storing asphaltenes, and has been successfully demonstrated using 3 different feedstocks in a 2-barrel-per-day pilot plant. This figure depicts KBR's the product ROS process. KBR's ROSE is deployed for refinery processing and heavy oil upgraders to process whole crude streams. Key features include supercritical solvent recovery and optional third stage to obtain a resin product, which can be hydrotreated, cracked or coked to yield more desirable products. KBR's ROSE flow is similar to the ROSE process but applicable for upstream projects to upgrade heavy oil and can be integrated with a steam generator where the asphaltene can be utilized as fuel for wells and reservoir facility. ROSE flow can also remove water and asphaltene while lowering viscosity. KBR's Aquaform is a low-cost option to handle asphaltenes by enhancing the ability to store and transport asphaltenes. UD's propane deasphalting is used for fuels or lubes production. The key benefit of this technology is in utility consumption for fuels production applications. A 720 metric ton per day unit was completed at a refinery in Poland. Here is a process diagram for UD's propane deasphalting technology.